Right, looking at the homework. Go ahead. Turn to page, I believe it's 38. So I've got two big questions about the homework that I want you to walk away with. So if you did not do number 2, yeah, it's on 38. One of the questions for the idea is, what is the equation for Galberto? First of all, what do we know about Galberto? What do we know? Read the problem there. Read number 2. Preston, read number 2. What do we know? Read it.
Me?
Yeah.
Oh, okay. In problem 2.2, Emil's friend Galberto joins the race. Galberto has a head start of 20 meters and walks at 2 meters per second. Write an equation that gives the relationship between Galberto's distance d from where Emil starts in the time t.
So he walks, so head start at 20, and he walks 2 meters per second. So we know two things about Galberto. So if I go to write an equation, I'm going to have an independent and dependent variable. I know that my dependent variable is always at the end. My independent variable is on the other side of the equation. And this independent variable works with my rate or my constant. It gets multiplied. And then I know that sometimes I have to add on my y-intercept. So I'm going to put y-inter. So here I've got this equation. What am I going to call my dependent variable in this equation? What is it? Is it time? Is it cost? What is it? Read the question. What is it asking? Distance. So I'm going to use D for distance. And then, do we know Galberto's rate? Ethan, do we know his rate?
Yes, 2 meters per second.
2 meters. So I take the R, I put a 2 there. Now, my independent variable, I never know chi. My dependent variable, independent variable are always variables. So if this is distance, what's the other variable? Time. So I'm going to put a T for time. And is there a y-intercept here? If I put 0 in for time, where does Galberto start? 20 meters. There's my y-intercept. So your y-intercept, Steve, the way you figure this out, you put a 0 in for your time. You're going to get a distance. Whatever that distance is for 0 is you have to ask yourself, where is he starting? That's your y-intercept. And I used both those. That became my y-intercept. So this was my y-intercept. His rate, Michaela? Yep. His rate is 2 meters per second. So how can I use an equation to picture what a graph might look like? So here's my equation. How can I use this equation to be like, what might this graph kind of look like? Talk to your partner. I know it's not. I made this one up. Yeah. Talk to your partner.
Well, if he has a 20-meter head start, he would have to start at 20.
Boom.
So yeah, he would start at the 20 while everyone else starts at 0. Exactly.
So I heard this, Skylar. He's got a 20 meter head start. And so Michaela said, one thing I know is I know that it's going to start at the 20 on the y. That's his y-intercept.
Because you got a 20-minute head start.
20 meter. So next, Bree, do we know what my y-intercept, do we know what my y-axis is? Look at your equation. Do I know what my do I know what my y-axis is? What is the y-axis?
The y-axis is the one going up.
What is it?
It's 2 times t plus 1.
What's my y?
2.
It is my distance. My y-axis is always my dependent variable. So this is distance, this axis. So if this axis is distance, what's the other one? Time. Your rate is a constant. You don't graph it, right? It's what shows up. So then this is time. One last thing. Julian, if I know the rate is 2, how steep is this line? It's pretty steep. So if the rate is 2, I know that this line is going to start at 20, and it's going to go like this. Okay? It's not flat, right? Flat would be a 0 rate. Preston, go reflect. Maybe if you were turned around facing forward, he wouldn't have to do that. Please, go. Reflect. Grab a sheet. Okay, so any questions about this piece here? This is what you need to know. My my y-axis is always my dependent variable, which is on this side of the equation. This is my independent variable. It's always my x-axis. So I got those on there, and then my y-intercept is where they start.